The broadcast is now starting. All attendees are in listen-only mode.
Welcome to the Develop Sound Corporate Policies with Enterprise Data Mapping webinar. This webinar will be presented by Jim McGann. Jim is the Vice President of Marketing at Index Engines. Jim has extensive experience with e-discovery and information management in the Fortune 2000 sector. He's a frequent writer and speaker on the topics of big data, backup tape remediation, electronic discovery, and records management. He has written articles for ARMA, ILTA, Forbes, Inside Counsel, and other leading publications. Please type any questions for Jim in the question area on the right of the screen, and he will answer them at the end of the webinar. So let's begin. Jim?
Thanks, Jen. Thanks, everybody, for joining tonight. Today I'm going to take you through a presentation talking about data mapping. If you do have questions, as Jen mentioned, feel free to type them in the question area, the chat area that you see on your screen, or the email address is there. You can send a direct question, and I'll put that up at the end of the session as well. So a quick introduction for those of you that are not familiar with Index Engines. We are an enterprise-class information management and archiving platform. So we're a software company that delivers software to help organizations manage information according to policy. One of the unique features is that the ability to manage across all classes of storage, including backup tapes and legacy data on tape, as well as your primary storage, including desktops and servers and so on, is a unique capability. Typical customer involvement is can be large-scale enterprises that have petabytes of data, including legacy data, in many different vertical markets. Very cost-effective solution, plug-and-play deployment, easy to get going, and the ability, once deployed, the ability to find, manage, and report on all your online and offline enterprise data assets. We've been in business since 2004. It is patented technology, so there's a lot of unique capability that's under the covers of the product, and we have quite a few clients in the Fortune 2000 space, government agencies. We also have a large practice around e-discovery, and legal-focused projects. We have quite a few service providers worldwide that provide services in that space. So clearly, everybody on the call here is really from large corporate environments or working with large corporate environments. It's no secret that it's a complex environment. There's large volumes of data. I mean, the data growth statistics are just really through the roof these days. But large volumes of data across user networks and servers. There's data in proprietary repositories, like email is basically a proprietary repository. Microsoft Exchange, IBM Lotus Notes, and others. It's a complex, semi-structured database environment. Backup is also a proprietary environment. So, the fact that data is large volumes and really in these proprietary formats makes it extremely complex. Organizations typically save everything. IT has been instructed really to make data available, and in doing so, they make copies of it, make sure it's replicated, make sure it's available at all times, so as not to impact the business. And organizations very rarely purge content. I mean, very rarely get rid of data. It's very difficult to understand what to keep, what not to keep, what should be retained for long-term in archives, and so on. Users also have a lot of control over the data. I mean, these days, users are saving significant volumes of data on their desktops. Desktops went from, megabytes to gigabytes, and now you can get a desktop with terabyte drives. So the ability to save significant volume and copy files to their desktops for their convenience is really becoming a challenge. And a lot of corporations that we work with are really putting, thin desktops out there where users really don't have the ability to store data. They're storing it on centrally managed servers, which is what we recommend as a good strategy. Also, users can take their email and create, PST archives of that content. PST archives are painful just because they're really unmanaged email archives that really show up in the most unusual places and really don't allow the content to be managed. So a lot of organizations really spend a lot of time understanding what exists, especially looking for things like PSTs, which need to be kind of centralized and controlled. So the fact that users can control those and create their mini archives on their own creates some challenges down the road. In general, there's a lack of knowledge across corporate data assets. So if the data is in a repository like an archive or a document management system or content management system, it can be managed a bit more effectively. If it's just loose out there on networks and email and so on, it becomes difficult to manage and control the content. And especially as the data ages, that becomes difficult to find. You know how difficult it is to find an old presentation or a spreadsheet or document on your desktop that's been, that you haven't looked at or managed for, 3, 4, 5 years. Think about the entire corporate environment. It becomes more complex. So here's some statistics. The first one from our friends at Gartner Group that talks about the data growth rate in a corporate environment is anywhere from 40 to 60% annually. So the fact that your IT organizations are continually adding storage to increase capacity, increase ability for users to create and store content is creating the making the challenge of managing that content much more complex. But 40 to 60% growth is significant. That's one of the larger numbers that I've seen over the past few years. So the trend is towards more data, across, more data, that needs to be managed. Another quote again from Gartner that talks about through 2013, the business case for 95% of information management programs will really depend on reducing IT costs and managing information risk. So it definitely ties into the trend that we're seeing where IT organizations are working hand in hand with legal organizations in order to really accomplish two high-level goals, which is really the goals of information governance programs, is managing risk, controlling liability, and protecting the organization, at the same time reducing IT costs. And clearly what we've seen is just by managing risk alone, you're going to reduce IT costs, because if you can see the next quote that's from the IBM folks, it's a great article if you haven't seen it, in Forbes this past July, that says, according to IBM, 69% of the information in most companies has no business, legal, or regulatory value. So the fact that business is growing at such astronomical rates, but overall the value of it, the business value of it, and the compliance or legal requirements to save any of it only focuses on about 30% of that content over the long term. So the bulk of it really could be recycled out or just purged, and that's not happening. And that's really where the corporate data centers are getting bloated and clogged with information. Most of it fine. Most of it can lay around forever. Some of it could be a liability, and it's stuff that needs to be managed that way. So the trend that we like the most out of all these 3 bullets here is that with IT and legal working together, they can really manage risk, and really the benefit to that is controlling their IT budgets, because you're really reducing the volume of data that's being saved. So in terms of classifying enterprise data, so we're talking about data mapping today. So data mapping is all about classification of content. There's really 3 high-level buckets that's really going to define the disposition of that data. A lot of the content, especially the current stuff, is going to be data that remains in place. No action is going to be required on that data. It's everyday working documents. Content with short-term business value. Documents and proposals and spreadsheets that are in process. There's really nothing that needs to happen to that content. So the fact that no action occurs, it's really going to remain where it resides, and that's really most of the current stuff that's being created. The 2 key areas in terms of classification are archiving. So it's really your intellectual property, content with long-term business value, stuff that you really need to keep for one reason or the other. The key driver here, however, that we're seeing is legal compliance, regulatory, e-discovery. So a legal hold and preservation archive is really going to support your legal teams, your compliance teams, and your general counsel's office. So it's really well-defined, mostly email, a lot of file content based on specific lawsuits or any kind of proactive compliance requirements that have to happen. And then there's the other piece, which is remediate. Remediate is kind of trashing the content that has no business value. Here's a good example that comes up frequently is, what about ex-employee data? As your employees leave the company, you can easily recycle their desktop or their laptop, but what about stuff they own that's out on the network? That stuff typically sits out there and just remains out there forever, and it's kind of unmanaged ex-employee content. So, I've heard from industry analysts that ex-employee data could represent as much as 40% of what's existing out of the network. So that's a big chunk of content. And if you're looking at Gartner's growth rates on storage statistics, they're saying enterprise storage or enterprise data is growing 40 to 60% a year. If you get rid of that ex-employee data that you have no need for, you could basically go through a whole year without increasing your storage capacity, which would be significant IT budgets there. So looking at the content that exists out there, being able to classify enterprise data into 3 major buckets. No action, we're just going to keep that data in place, archive it for long-term preservation or legal compliance, or remediate it. There's no value to that content. It's just taking up space and can be purged. And again, if you look at ex-employee data being 40%, and then the other stuff that has no value, these numbers here, as IBM said, could easily reach into the 60% zone of reclaiming that capacity. So an enterprise data map, there's traditional methods of doing it. I mean, traditionally, in order to develop the data map, which is really an inventory of user data sources to support your information management and information governance processes. Traditional process has really been around interviews. So interviews are really going to allow you to understand the history of the data sources, the relationship between users, applications, and so on. So, typical interview process would be really to talk to, IT organizations and departmental heads to understand where do you keep your data, what type of data do you create, what applications do you use, what versions do you use, is your email server Exchange 2005, Exchange, 2010, when did you upgrade? So kind of create that whole historical perspective on what was used to create content and where it resides and who owns it and so on. It's a really arduous process, very complex, very time-consuming, and really difficult to maintain. There's a lot of value in it because you can really get some key information from these interviews. However, profiling the data, this is what we're talking about today, using technology to create this data profile. You can, have indexing technologies scan the server, scan all data types, including legacy data on legacy backup tapes, and to understand the data types, the locations, user profiles, the age of the content, and really understand what exists out there. So what we're saying with data mapping is using technology is going to get you there much faster, but combining that technology with the interviews, you're really going to get a more accurate and comprehensive view of the corporate data structure and environment, including way back in your legacy content with working with backup tapes. So in order to do that, the challenge is there's thousands and thousands of servers and desktops. We're talking hundreds of terabytes or petabytes of data. Very dynamic environment, continually changing, massive amount of data, very complex. So in the past, it's been very difficult to understand what exists. There's really no clear understanding of sensitive data, and data mapping has a number of different benefits. One of them, obviously, being to streamline your storage environment. But what we're talking about today is to help you really understand where the sensitive data is, develop policies in order to support litigation and e-discovery efforts and regulation and compliance requirements. Data mapping has been dependent on IT knowledge, so when you're, without using technology, you need to talk to the IT folks and find out, who owns that server, what department stores data on it, what type of data it is, and go through that conversation with them. As that organization changes, you'll lose that knowledge. So, IT folks that have been involved in implementing certain servers and environments may be leaving and changing jobs, and you may find that that knowledge is slowly weeding itself away. As well as data ages, it becomes less mappable. So in the traditional environment, no one really knows what's on, 10-year-old backup tapes. It becomes a mystery. So in order to use technology to index enterprise data sources and really get an accurate profile of that content, there's really two options. The first option is crawling networks. So in order to crawl networks, you're going to have to basically crawl through the network file systems and index the files and emails. So basically it's going to scan it and look for what exists and extract the metadata profile of that content. So with the light index, it's going to be very fast. It's going to basically, try to get through that content very quickly so it's not to impact the user's ability to leverage the network. So the indexing process must be very high speed and intelligent. The fact that as the data is going to be changing, it's important to have incremental updates that allow for continuous refresh. So as users change data, modify data, create new data, you don't want to have to go in and scan everything. You can just look for the incremental changes in order to refresh the data map or the index. And it must be scalable and economical. I mean, in order to do a data map, if you need to index your content with technology that's going to cost you, millions and millions of dollars, something that's not going to happen. The payback won't be there. So it's got to be a scalable, economical solution. The other option, which is, well, actually, let me talk about a little bit further down the slides. But coming back to network crawling, the solution that we have here at Index Engines is our Octane platform for networks is the highest speed indexing platform of the market today. So indexing at 1 terabyte per hour allows you to very quickly process data. Also, many clients have implemented multi-node environments to support petabytes of content and indexing that data very efficiently. And the fact that even environments that do have petabytes of data can really benefit from terabyte per hour indexing in that it's a very intelligent process that'll really incrementally update data as it changes and intelligently skip through irrelevant content. So the idea is that if you have high speed and incremental and intelligent processing, you're really going to reduce your indexing bandwidth requirements and really not impact the users, especially after you get through your initial index, which is really going to take the bulk of the time. The incremental updates happen pretty much transparently. One of the benefits of the platform is scalability, so it's a very small index footprint. So if you're indexing 1 terabyte of data, the footprint isn't half a terabyte or 3/4 of a terabyte in order to process that stuff. So it really allows for extreme scalability and minimize storage requirements. So in fact, a single indexing node can index up to over 70 terabytes of data, depending on the formats. And that all allows for cost-effective solutions. So minimal support management required, low cost per terabyte for enterprise-class indexing environments. So the fact that you have the ability to plug in individual nodes onto the network, get very high-speed, efficient indexing, will allow you to really process and data map the content that exists. The other option I mentioned here for indexing the data is leveraging the backup process. And this is kind of a disruptive idea. I mean, a lot of people haven't thought about doing this because really technology doesn't exist to do it until we released our indexing capability to index backup environments. So if you think about it, your IT organization already has a backup disaster recovery process in place. And what that's doing is crawling the network, it's finding what's new and different, and backing that stuff up to backup tapes or backup disks to be able to make sure it's protected for any kind of disaster recovery or business continuity activity. So really the backup process is really the best source to find out about everything that exists on your network, including files and emails. It's really a snapshot of that environment, and it has been difficult to tap into to really leverage, but we make that easy. So it's an interesting approach. In order to create a data map, we actually went through this project with a client where a full backup of their environment with 70 backup tapes. That was everything. And the full backup occurred over a weekend time frame. So what we did is they were interested in kind of mapping out to do some policy audits and to help develop and fine-tune their policies. We took those 70 tapes, indexed that content, and that's basically a complete index of all their network environment without having to crawl any of their servers or filers. So it's convenient, it's easy, it's non-disruptive, and doesn't have any impact on the network infrastructure. So, again, these backup tapes here, again, are a snapshot of the network, so it's really the best source of knowledge. You can create, it happens on a weekly basis. It's easy for IT organizations to create it or to, create a copy of those backups. Doesn't take any time at all. It's non-evasive, as I said, incrementally updatable. So if you do a full index of all that data, you'd have a full snapshot of your corporate network environment. If you do an incremental update the next week, it's going to incrementally update that snapshot. So again, direct indexing of backups is a unique feature here at Index Engine. We can extract detailed knowledge of the networks, by scanning the tapes. We developed this metadata index, which is really what's going to be used for data mapping. It really extracts all the user profile content, what users own, where it is, what's the age, and so on. Server profiles, what applications and data exist on server, who owns the data on those servers, and so on. Very powerful canned reports, which allow you to kind of dynamically look at the content at a high level and analyze it, determine where the sensitive content resides. So with these backup tapes, what we've done is really unlock those backup formats, make it accessible. It is our unique proprietary technology, and it really has a huge benefit here for data mapping. Is it practical? A lot of organizations are like, this sounds like it's a complex process. If you look at a full backup, it is readily available. I mean, IT is going to take their backup copy for disaster recovery and lock it up, but making a copy of that or replicating that process is not a difficult thing to do. So basically, the full backup is readily available. It's an offline process. It can be done in a lab. It doesn't need to be done on the network. And if you look at an example of, half a petabyte of user data, so 500 terabytes. So if you look at them, IT backing it up, if they're using LTO4 tapes, which are, pretty commonly used out there, it's going to take up about 300 tapes. So each tape is about 1.6 terabytes each. So using a library, and libraries are great for working with backup tapes, because libraries basically like a jukebox. You can load up a bunch of tapes in this library and have the robot of the library just manually process tape after tape after tape. So it allows parallel processing and automated processing of the tapes. It'll basically take about 2 weeks. So in 2 weeks, you can have a complete detailed profile of all the content that exists out there in the network, far quicker than a traditional data mapping process. So it gives you really high-level view through the reports, as well as detailed file listings and information. So not only will we create a data map, but it could be an actionable data map that allows you to clean up and manage the data. And you can incrementally update it. So if after 2 weeks you want to get a refresh, you can go and just get an incremental update from that last full backup, which is going to be a small number of tapes, and just add that to the index. It'll just keep it fresh. So again, you can have a very rich index of that content, allow you to really profile user data that exists. So in the indexing process, whether you're indexing off of backup tapes or network disk, through the scanning process, you're going to output a rich metadata content, including things like when the data was last modified, which is always a common request, because modification time is going to give you a view into how useful that data is. The owner is also very powerful. Document name, location, things like that. This is a partial list of all the metadata fields that will be processed. So the fact that you'll have this in a queryable, actionable database gives you really power over that information. You can also output load files. So a lot of organizations will create this data map and output listings and file listings and locations that can be leveraged by other platforms and applications. So this could be a CSV text file output. It can be based in a query, so you could basically focus on a specific server or a specific user and say, where are all of John Doe's files across the network? As I mentioned, once you have the index, it is an asset that you can use over and over again in order to query, in order to report on it, in order to take action on the data. There's a web-based GUI. I'll show you some screenshots a little bit later. That way you can perform these iterative queries. For example, you can say, server name, find me the types of data that exist on a specific server, what users have data here, what's the age of that data. So you can iterate yourself into those specific queries or policies. User type profiling, you can say, user location based on certain users. You can say, where's all the location of the data, how old is it, what type, based on date range. When was data last modified? So you can say what modifications or what content was not modified in the past 5 years. Does that data have any value? Is there any legal or compliance reasons to keep it? You can even do keyword search if you do a deep index here, where you can find users who have specific content containing maybe sensitive keyword around your intellectual property or manufacturing process or so on. So one of the things we see that's fairly common is user-based mapping. So if, for example, you were looking at a number of users, these 5 users, and they're in, say, the finance department, it could be 500 users, more than that or less. You can import a list of custodians. So there's the ability to import a custodian list or a username list into the interface. And by doing that, you can generate a report of where all the location of their data is. So say for these 5 users, keeping it simple, you'd expect that all the data would exist on server X, which is the finance department server. But based on this query, you're going to see that a percentage of data exists on server Y, which is a server that's outside the finance department, and for some reason you got a bunch of these guys storing data on the server. Copy of their files are also going to show up on legacy backup tapes, and also obviously in the email server, which is a separate environment. So you can see, by using the data mapping of this index that was built, you can get a quick profile of a specific list of users. Again, this could be 1,000 users. Show me where all the data resides. Once you have that information, you can start doing some profiling. And again, the queries in the interface are very dynamic. So you can say, show me the type of data that exists. Email, files, databases, and so on. What's the age of the data? So you can say, show me the type of data and look for a specific file type, like PDF, for example. What's the age of the PDFs? When were they created? You can also look for email and look at email exchanges, frequency of communication. You can look for data that typically has been hidden, like PSTs on remote servers. You can look for shared and duplicate content if you do a full text index of there. So a lot of different iterative type queries that'll help you develop those policies. The reports, which I'll show you a couple screenshots, are again dynamic. You can drill down to them. So you can here report on a specific custodian. So say, for example, I could say, show me all of John Doe's data, determine where they stored spreadsheets, find other users who stored spreadsheets on the server, and determine which spreadsheets were accessed in the last 90 days by users and so on. So you can kind of ask questions to the index, to the query the index, and help understand and profile the content, and help develop policy. You can also help it to use this to audit your policies or to fine-tune your policies. So we work with an organization that has a policy that they don't allow users to create PSTs on their desktop just because they were difficult to manage email archives. So they've had that in place for a while. What we did is we did an audit for their environment and indexed the full backup, which is about 70 tapes. So we indexed all those 70 tapes and did a report and said, show me the file types that exist in the network. And sure enough, there was tens of thousands of PSTs that exist now on the network. So the fact that you have a policy is one thing, but enforcing it and auditing it is really key, and that's really the power of the data map here. So the reports can be customized, fully downloadable, so you can create the reports and download the data, and you see a list of some of the typical reports that exist. So here's a screenshot of one of the reports. This is looking by owners. So if you look in the report here, you can see owners by file count. And here what you can do is you can select specific locations. So again, it's very dynamic and very iterative. So you can select the locations tab and say, I'm just interested in this, these 5 locations. So filter down, just hit the checkbox and say, okay, I only want to see data that's in those locations. And then I want to select the report, which is the owner report. And you can see here that based on those locations, John Doe, our friend John Doe here, is the #1 owner. He owns 62% of the files on those servers by count. You can see the bulk of it is really owned by John Doe. So, a quick analysis there will give you an idea where who manages that data. So this is a report by file type. So again, you can select specific locations. Here again, those 5 servers located, and switch the report by file type by file count. And you're going to see here that 82% of the data is exchange messages. 9% is really word perfect, and so on. So you could really customize the queries, which will really customize the report. For example, here in this report, if I'm not interested in exchange messages, you can just uncheck this box and say, just these file types that are checked, what's the percentage of the numbers of those types of files. Another report is a report by the age of the data. This one's fairly common for data mapping and kind of cleaning up and reclaiming storage capacity and managing networks. You can do the report by age. So again, selecting specific locations. This is a canned report saying in this case, is a modified time report. There's a bunch of options here. You can change created time and so on. But there's a few others. Modified time, last access time, and so on. So you can see of these locations here, 36% of the data hasn't been accessed in 2 to 3 years. Another about third of the data has been accessed in more than 5 years. So you can see, if you look at 2 years or greater, the majority of the data hasn't been accessed in that time period. So useful information. Another report which I love is really the sender-receiver domain reports. This is about email. So you can go in there and you can browse through, this is an email server here. You can see through the Exchange database, and you can see different custodian mailboxes. So you can filter this down to a specific custodian mailbox, say John Doe, and say, I want to see who's been sending email to John Doe and who's been receiving email from John Doe. So you can see here, this is the sender domain report here. So you can see the #1 sender of email here, about 21%. To sender John Doe is Google Groups. #3 is Iron Mountain. Okay, so you can just see #5 is Deloitte. #6 is Quantum. So you can get an idea from the domains of who's sending this person email. So that's good. It's good for organizing the email. It's also good for your discovery activity in order to cull and filter through the data as well. And all these reports can be exported to a CSV text file and used as a load file for other platforms as well. One of the key points that I think I mentioned earlier, but I want to reiterate, is that you could definitely upload a list of user mailbox names and so on. So this is a useful report to be able to narrow the scope. For example, you have a list of ex-employees. It could be 500 or 1,000 or 2,000 ex-employees. You just upload that as a CSV into the interface, and you can see here a list instead of typing those names in. So it makes it easy to be able to import those query terms and say, I want to upload a list of ex-employees or these employees under legal hold, and create a policy here saying any content owned by these folks, these custodians, I want to make sure I have a policy set up to put that, migrate that data into a legal hold and preservation archive. So beyond the data mapping, the important point here is that the data mapping is actionable. So it's a full index of your enterprise data. It's a really big asset to be owned by the organization. So by implementing this, the IT organization could really provide a significant benefit to many different departments within the organization, from legal compliance to e-discovery and others. It can be leveraged really to respond to legal requests. So a lot of organizations have had a lot of pain and expense around e-discovery or legal requests. Having a data map allows you to just look at the data map. It'll point to where the data resides, so your identification and collection efforts are really streamlined, more cost-effective, and less painful than the traditional process. Having a data map also allows you to perform early case assessment or early data assessment on the content. So instead of having to wait for your discovery periods, you can really look into the data environment and the data map and really understand your exposure, liability, and risk in order to develop a proper strategy for pending or current lawsuits. The other thing is defensible deletion. We just did a webinar yesterday on defensible deletion, but that's really defensively cleaning up, kind of getting your data house in order and cleaning up old files and emails in order to manage long-term liability. So an actionable data map, one that you do create, takes some effort to create. You have to scan those different sources. Again, using backup tapes is one of the key advantages here, that we can make that happen pretty quick. But otherwise, you need to scan through your network data sources and create that actionable data map. But once you have it, you can see there's many different benefits. So here's an example of some data maps in use. This is involving current litigation. So if you need to find all email conversations between John Doe as one user, a custodian, and Sue Clark from June 2008 to January 2009. So the data map could determine that email is on an active Exchange server. It could also tell you that it's also on backup tapes. It could also tell you that email is on desktop PSTs. So in e-discovery or litigation, you're typically spend a lot of time finding and collecting data, and a lot of that time is spent deduping, common data that exists in similar repositories. So here, looking at email, again, there's multiple places that this email could be, and the data map will tell you that. You can query the index of the data map and extract the responsive data. So if you say, hey, I need this data, and I know it's on the Exchange server, I know it's on a specific PSTs, you can point to those locations and extract the responsive content out. And for tapes, the nice thing about tapes is you're not going to impact your production environment. It's really an offline environment. The only requirement is the offline tapes need to be mounted so the data can be extracted from them. And then all the content could be easily migrated into a legal hold archive for review and for preservation and review. So the data map here basically takes all the mystery out of where do I need to look for this stuff. So the identification and collection process is really streamlined. And I know in talking to customers, that could be one of the most costly components to their litigation support activities. It's just finding the content. They could spend a significant amount of time doing that. Another example is defensible deletion. Defensible deletion is gaining a lot of traction. Customers are coming to us saying, I know I need to get rid of stuff, I just don't know what to get rid of. So that's where you can turn to this data map. And I mentioned earlier the ex-employee angle, which is really has a lot of interest out there just because it cleans up a significant volume of stuff. So finding all files and emails from ex-employees that are not on legal hold. So there you can upload a list of ex-employees into the interface. Say, show me all the stuff that's owned by these guys. and then you can cross-reference it by any of these folks that are not on legal hold. So if there are folks that are on legal hold, you can take it out of the query and just get a list of people that have no legal or compliance or regulatory requirements against them. You can review the data map, find where that content exists, and then extract that content out and move it into the archive. So one other thing you can do here is find, has the data been accessed at any period of time? So if you do have an ex-employee that left a bunch of data on there, if other employees, current employees are accessing it, leveraging it, you really don't want to pull it out from under them or purge it. You want to just leave it in place and let them do that and get their job done. So in terms of the actionable data map here, it'll give you a tool to execute a defensible deletion program. And again, if the end result here is really to purge, ex-employee files, again, from the earlier statistics, we're seeing, upwards of 40% of your data that's on your network can satisfy this criteria. Finally, the third example is enterprise early data assessment. If you have existing lawsuits, say a harassment lawsuit between two employees, before you get to the discovery process and so on, you can query the data map to determine where the email exists, find that content, and if it's if all the employees that are doing are up to no good, some of that stuff could be hidden on PSDs or kind of archived off onto their desktop and not as easy to find on the email server. So the data map can tell you all the sources of that content and allow you to query it and find specific sensitive activity that may be going on. So you can find the relevant email and review that content, determine is there any kind of action that needs to be taken, sooner rather than later in order to protect the organization. So early data assessment is a powerful capability that can leverage data map. So, wrapping things up, I know we're almost at the end of our 45 minutes or so. There's a lot of advantages to data mapping. Obviously, customers talk to us all the time about providing better insight into their corporate data assets. They really need an information discovery or information management layer. Allows you to streamline storage capacity. So, again, some of the statistics saying anywhere from 40 to 60 or 70% of storage capacity contains content that could be purged easily without losing any business value or overriding any legal or compliance requirements. That's a huge cost benefit to any organization. Helps you develop policies, helps you refine your policies, fine-tune the policies, helps you develop policy audits, helps you improve your support for legal and compliance, and just really finding and managing data more effectively is definitely becoming a best practice out there in any organization. Okay, so some clients that are using different components of the Index Engines platform, from government agencies to corporate clients across the board. I see now that we're at 2:45 here, so I know we need to wrap things up. But I know we do have a white paper. So this white paper about how to use data mapping to manage liability, it talks about policy, it talks about reclaiming storage capacity, is available. If you want to send an email, and my address is sitting there on the screen right now, you can shoot me an email and I'll get you a copy of that white paper directly, or I will, if you want a copy of the presentation of the slide deck, I'm happy to get that to you as well. Also, we didn't have time for a demonstration today, so if anybody on here does want a demonstration, I'd be happy to arrange that at your earliest convenience. Okay, so thank you all for your time. Appreciate it, and hopefully we'll be talking to you in the future. Thank you, and have a good day.